fibroblasts, the stem cell. Your red blood cells, white blood cells, platelets, all come from this same stem cell. So this is called pluripotent. Pluripotent stem cell. Why? Because it can go to any direction. It can produce white blood cell, produce red blood cell, produce platelets. Pluri. Multiple. Okay. Location of the production of blood cells. Before birth, in fetus, blood cells are produced in the liver, thymus, spleen, lymph nodes, and red bone marrow. So, other organs also produce, not only the red bone marrow, but other organs like liver, spleen, thymus also produce plenty of blood cells. But if you see after birth, then red bone marrow is the primary site for the blood cell production. So after birth, blood cells are produced mostly by the red bone marrow. And in early part of your life, all bones, almost all bones are filled with red bone marrow. Everywhere you will find red bone marrow. Okay? And in adults, only the red bone marrow is present at the ends of the long bones, not in the shaft. In early part of life, you have everywhere, just simple. You have red bone marrow everywhere inside the bones. And in adults, red bone marrow is present only at the ends of the long bones and inside the flat bones. Inside the flat bones, like sternum, cranial bones, not inside the shaft. Inside the shaft, what happens? The red bone marrow becomes yellow bone marrow, which is fat, adipose tissue. So here, the red bone marrow is replaced by fat or adipose tissue. Is it clear? So red bone marrow only is found at the ends, not in the shaft. And that adipose tissue or fat is called yellow bone marrow. So that's where you will find the red bone marrow at different stages of life. Erythropoiesis. Poiesis is production. So erythrocytes are red blood cells, right? Remember that? Erythrocytes are what? Red blood cells. So erythropoiesis is the process of production of red blood cells. The process of production of red blood cells is called erythropoiesis. Make sense? Leukocytes are what? Yes, allowed. You're right. White blood cells, right? White blood cells are also called leukocytes. Make sense? So if I say leukopoiesis, that indicates what? Production of white blood cells. Make sense? Erythrocytes are red blood cells. So if I say erythropoiesis, production of red blood cells, right? If I say leukopoiesis, production of white blood cells. Okay? Now, factors stimulate erythropoiesis. Which factors stimulate the production of red blood cells? I mentioned before. One is if your body needs more oxygen. Make sense? Red blood cell production increases. when your body needs more oxygen, if you go on the top of the mountain, high mountain, right, where oxygen pressure is low. So your body needs more oxygen, right? So how the body will, act in that situation? By producing more red blood cells. So transport will be more. Hypoxia, that is called lack of oxygen in the top of the mountain or somewhere in your body. If the oxygen is low in the tissue, that is called hypoxia. So hypoxia or low oxygen will stimulate the production of red blood cell, number one. Is it clear? Hypoxia or low oxygen in the tissue. Number two, I mentioned that sex hormone, testosterone, right? That's why in male body the red blood cell is more. And number three, I said in the kidney you have a chemical that is called renal erythropoietin. Renal means kidney, erythropoietin. Its name is telling you, erythro means red blood cells, right? Poietin does poiesis. Poiesis is production. So those are three factors that stimulate the production of red blood cells. I have already mentioned maturation of red blood cell. What are the changes? Three changes. Remember that? From immature to mature. Cell size will get what? Bigger or smaller? Smaller. That is reduction of cell size. It should be size, not size. Okay? Size. Number two, appearance of hemoglobin. And number three, disappearance of nucleus. Ejection of nucleus will be kicked out. So now let's see those three changes. So this is the early stage of red blood cell. Larger, has a nucleus, no hemoglobin. Make sense? Larger, has a nucleus, no hemoglobin. Then gradually it's getting smaller, you see here, and go through different stages of maturation. This is called proerythroblast. So what happens actually, you see hemocytoblast gives all types of blood cells. So from hemocytoblast, those cells will produce red blood cells. Those are called proerythroblast. This one, proerythroblast. Then it will become erythroblast. Remember, blast means immature and cyte means mature. So all these are blasts because they are still immature. Okay? Then erythroblast, not erythrocyte, erythroblast. That means immature red blood cell. And then normoblast. When the size becomes close to normal red blood cell size, that is called normoblast stage. And then from the bone marrow, this is bone marrow, the red blood cell will enter into the blood circulation in the blood vessels, capillaries. Just before that, the nucleus is kicked out. Makes sense? Nucleus is pushed out. So nucleus will get out from the cell. Make sense? No nucleus inside. And you see the hemoglobin, these tiny structures will get together and form the hemoglobin inside. Okay? So synthesis of hemoglobin will occur. So those are the changes during maturation. If I ask you in which stage the nucleus is kicked out or ejected, that is the normoblast. Okay? Just before it enters from the bone marrow into the blood vessel, capillary. And after it enters into the capillary, this stage is now called reticulocyte. And then it becomes erythrocyte or mature red blood cell. So those are the stages and changes. Lifespan of a red blood cell. A red blood cell has 90 to 120 days lifespan. That means it stays alive 92, 3 to 4 months, right? 3 to 4 months. After that, the cell membrane becomes fragile, very weak, and lysis of the cell occurs. Lysis means what? Breakdown, right? Lysis of the cell membrane. So, why the lifespan of a red blood cell is that short? Your neural tissue can stay alive for 100 years or more, right? But red blood cells only 3 to 4 months. So all of your red blood cells are being replaced by new red blood cells, right? After 3 to 4 months. The reason is simple. Red blood cell doesn't have what? Nucleus, right? Nucleus is called the control center of the cell. You know that. It controls the function, right? So if any cell doesn't have nucleus, that cell will not stay, will not survive that long. That's why after 90 to 120 days, the cell membrane, due to low metabolic activity, the cell membrane gets weak and rupture occurs. Make sense? And if the rupture of the red blood cell occurs, then who will come out? Hemoglobin. Because red blood cell has hemoglobin inside, right? Hemoglobin comes out. And hemoglobin, its name is telling you. Hemoglobin has two parts. Hem and what? Globin. That's why hemoglobin, right? Hem part has iron. This is iron, right? In ferrous form, 2+. And other chemicals. Just know that heme has iron and other chemicals. Iron binds with oxygen. This is very important. Binds with oxygen. That is heme. Globin is protein. Consists of 2 alpha and 2 beta chains. So that is the protein part or globin part. Make sense? So hemoglobin has how many parts? 2 parts. Heme and globin. The main chemical of heme is what? Iron, which binds with oxygen. Okay? Iron is in ferrous form. Ferrous. Ferrous. That means 2 positive charge. Ferric form is not good. If it is like this iron is not good to bind with oxygen. This one is good. Okay? So we don't need this one. And other chemicals. And protein consists of amino acids, alpha and beta chains. Okay, so let's stop here today. So we'll start from this one next class.